And welcome to the second Calem Cymraeg psychology session for March 2022. Today's session will be run by myself, Miss Bellis, and I teach psychology at the Allen School. Today's session is following on from the session that I did last week, and you will find all of the session resources, the PowerPoint and this video in the Calem Cymru section of the e-sgol website. All right, so within these sessions then, there are 4 different areas that we are focusing on. The first session looked at the dopamine hypothesis within the biological explanations of schizophrenia. We looked at what the dopamine hypothesis is and then how to tackle that if it came up in the exam as a describe question. In today's session, we are sticking with our biological explanations, but we're going to look at the second explanation, which is structural brain abnormalities. So we'll look at description of core knowledge and research around structural abnormalities of schizophrenia. Okay, so we are still within Unit 3, Implications of the Real World, and we are looking at Section A, which is the study of behaviours. So your school or college will have chosen 3 behaviours, and everybody's might be different. I'm focusing on schizophrenia today. So you will look at 3 behaviours, 2 of them obviously with our condensed specification because of the pandemic, but yes, 2 behaviours you should know, and you should know all of these different areas about those behaviours. So it says Section A, the study of behaviours. Learners must choose to study 3, or this year it's 2, from 6 nominated behaviours. And the section in red is where I am focusing this session on today. Understanding biological individual differences and social psychological explanations for the behaviour. So that is the plan, and we're going to have a look at the content of an essay question, and then I have an essay plan and some mark schemes to look at with you as well. All right, so focusing on schizophrenia. One thing that's really, really important to remember throughout all of these sessions is the characteristics of schizophrenia, or the characteristics of any of the behaviours that you might be looking at. They're really important, and they crop up in every single essay question. So no matter what the question is, you will have to use the characteristics of that behaviour to help you. Okay, so we've looked at the dopamine hypothesis, that was the previous session, and today is all about structural abnormalities. We're looking at the structure of the brain and the changes and the differences that people with schizophrenia might have in their brain. So let's start with a little bit of background on this. So we know psychologists believe that schizophrenia is caused by neurotransmitters in the brain. That is what the whole of the dopamine hypothesis is about. They say it's too much dopamine. They say that it's focused in your limbic system between the mesolimbic and the mesocortical pathways. We know that. But others have considered how the brain works on a much larger scale. And this is something that was created many years ago. So when we look at the background research of this, Emil Kraepelin is your researcher. And one of the things I want you to do is note the years that I have put in brackets on the screen, 1856 to 1926. He was one of the first psychiatrists to classify schizophrenia, or at the time he called it dementia precox. And he said it's an organic brain disease. It's all to do with the function and the structure of your brain. But it was massively overshadowed by a psychologist who I know that you are all familiar with, Sigmund Freud. And Sigmund Freud's theories are controversial, they are different, and lots of people believed him rather than Emil Kraepelin. So it was completely overlooked, and people thought that it was nonsense, and they focused way more on Freud's theories. Freud's theories are one of the elements that we're going to be looking at next week in this session. So they haven't looked at enulcrapulin. They don't think it's an organic brain disease, but as time went on and our technologies developed, we were able to consider brain scanning techniques, and we now have lots of different types of technology, don't we? We've got PET scans, we've got MRI scans, we've got CAT scans. We have the ability to inject a person with a tracer and have a look at the active brain. So we have way more knowledge of the structure of the brain now and how it works, and that's massively helped in our explanation of schizophrenia, especially the structural abnormalities. So it says here, modern researchers have produced much evidence to support Kraepelin's early ideas about brain disease, identifying structural abnormalities in the brains of those with schizophrenia. So we actually have a little bit of empirical scientific evidence now, which obviously we didn't have before with Freud's theory. The first element of this is about ventricles in your brain. Now, a ventricle is just a gap. It's a space in the brain, and it is where we create and transport cerebral spinal fluid. Now, you will know that cerebral spinal fluid is a fluid that is centered all the way over the cortex of your brain, and it's also in your spine. And it's really, really important that we have cerebral spinal fluid and that we're able to test it, because it really helps us understand different types of conditions that a person may have, because we can look at metabolite levels in a person's fluid, which means that we can do lots of different medical interventions. So it's really important that our brain creates cerebral spinal fluid and transports it in the right places. Fluid protects our brain, it gives it buoyancy and chemical stability. And that is what is created and stored in our ventricles. That's what's in the gaps in our brain. Now, one thing that's really apparent in people with schizophrenia is that their ventricles are enlarged. They are bigger than a normal functioning brain or a person without psychosis. There are 4 ventricles in your brain that you need to be aware of. Now, in the exam, you won't need to label them, but you would have to explain where they are and where they're sort of situated in the brain as well. So you've got 4. You have the left and the right lateral ventricles. You have the 3rd ventricle, and then you have the 4th ventricle. The left and the right lateral ventricles are, and I'm hoping you can see my mouse on the screen, they are this gap here underneath this structure here, which connects the 2 hemispheres together. So this gap here, that is your lateral ventricle. Now, 1 and 2 are your lateral ventricles because you have one on either hemisphere. So you have a lateral ventricle this side and a lateral ventricle this side, hence why it's 2, okay? Then you have got your 3rd ventricle, number 3, which is situated between the left and the right thalamus. So your thalamus is here. It's quite central to your brain, in the middle of your brain, quite central. And on this image, you can't really see the fact that it's a space, but that's because it's an indentation in this image. But if you have 2 indentations in the brain, when you put the brain together and you put the 2 hemispheres together, they create a space. And that's what your thalamus does, okay? A really nice way to remember this is that the 3rd ventricle, 3rd begins with a T, is by your thalamus, and that also begins with a T. And then you've got your 4th ventricle, which lies between the pons and the medulla oblongata. So here, this sort of bulbous area, that is your pons, and this element down here, that is your brain stem. So the 4th ventricle lies between the pons and the medulla oblongata. This triangle here, that is your 4th ventricle there. Okay. So you've got 1 and 2 lateral ventricles. You've got the 3rd ventricle here, and then you have got your fourth ventricle right there. They are spaces in the brain that create and store cerebral spinal fluid. And in people with schizophrenia, they are normally much larger. Here are some more images then of these ventricles. So this is from the side, isn't it? It's a side view of the brain. This is the back. This is your cerebellum. Here's your brainstem. Here's the front. This is your frontal cortex. The red area here, that's your lateral ventricle. You've got two, one in each hemisphere. You then have your third ventricle by your thalamus in the centre. And then down here, this is your pons. You have got a triangular shaped one, which is your fourth ventricle. And then another image, just in case it's a bit tricky to see on that one. This is it from a sort of a central view of the brain. So again, those brown ones that you can see, they are both your lateral ventricles. Third ventricle is in the middle and the fourth is a little bit lower. So those are our ventricles. Now, with every element of this, you need to be able to explain what the structural abnormality is, and then you need to provide a little bit of evidence. Okay, so this is the really tricky part, because we need to remember some key bits of evidence to back up the fact that we now have this scientific view of schizophrenia. So it says here, in some individuals with schizophrenia, the ventricles seem to be larger than those individuals without schizophrenia. And then you've got Daniel Weinberger, okay, and he used a CAT scan, and he reported that ventricular size was greater in a group of 58 individuals with chronic schizophrenia. So some things to note there. You have got a CAT scan, which we know is a really scientific method of scanning and looking at structures of brains. So that's a really good piece of evidence already. They've got quite a nice significant value within the sample that they used. So it says ventricular size was greater in a group of 58 individuals, and they had a control group. They compared it to 56 people without schizophrenia. So quite a decent number of participants, and a significant result there to show that ventricular size is larger in people with schizophrenia. So really nice piece of evidence there, massively in favour of this structural abnormality. Another image just to show you it from a more sort of scientific way, and it shows you a scan of the brain. So pretty self-explanatory. This side here you have got your schizophrenic brain, and as you can see, these two are your lateral ventricles because you've got two, one in each hemisphere. And then this is a healthy brain, or a normal functioning brain. And there is a significant difference, isn't there, between the ventricle sizes in each brain. One thing to note as well is that in Daniel Weinberger's research, he says it's chronic schizophrenia. Chronic schizophrenia means that it's quite bad, and that it means that it won't really ever get better. So maybe structural abnormalities like enlarged ventricles are exclusive to people that have quite a severe form of this psychosis, but nevertheless it's a really good explanation as to why their behaviour is so abnormal. So a really nice image there for you to have a look at, and that clearly shows that enlarged ventricles are apparent with schizophrenic brains. More evidence now, okay, so we need to make sure that we've got plenty of evidence in our exam question. So you have got Nancy Anderson, 1988, studied an MRI scan. So Daniel Weinberger was a CAT scan and Nancy Anderson was an MRI scan, so another really scientific way of looking at the brain. They scanned individuals with and without schizophrenia, so again, looking at that comparison. She found that those with schizophrenia had ventricles which were 20 to 50% larger than in control groups. These are significant differences and so indicate a structural abnormality. It's a very big difference, isn't it? Even just 20% larger. So again, a lovely piece of evidence to bring in to an answer here. Okay, so that's our first section. That's our first structural abnormality, enlarged ventricles. There are other further abnormalities that you can bring into an exam answer here. So the idea is something called cortical atrophy. Cortical, we know, means the cortex. It means the whole of the brain. And atrophy is meaning the loss of the neurons in the cerebral cortex. So all the way across our brain, we lose neurons, okay? They die, they decay. Cortical atrophy can occur all over the brain, and it makes it look as though the brain has shrunk because obviously we've lost those neurons. Or the atrophy can be focused in a limited area. So you can have posterior cortical atrophy, which means at the back of your brain, or anterior cortical atrophy, which means the front of your brain. So it can be all over, front or back, or in a specific area. In the latter case, the atrophy obviously affects the cognitive function of that area of the cortex. So that is what our symptom would be, okay? The symptom that a person with schizophrenia would show would be a lack of cognitive function. Remember, your main cognitive functions are memory, attention, and perception, aren't they? Okay, or the ability to follow and understand an instruction. So that's what would start to happen. Those would be your main symptoms. And then you would have a brain scan, and maybe they would show that you have a loss of neurons in your cortex. So with this loss of neurons in the cortex, the atrophy results in the widening of the grooves covering the cerebral cortex. So we've got lots of the like squiggly lines when you see them on a picture, but they are called sulci. And what happens is when your neurons decay or you lose them, the sulci in your brain get wider, almost to try and compensate for the fact that you're actually losing, you know, mass in your brain. And that type of damage can appear to characterise the brains of 20 to 35% of people with chronic schizophrenia. Again, emphasis on the word chronic. So again, this is, you know, a considerable amount of people that may have cortical atrophy in an area of their brain that can really impact on their cognitive function. Okay, so that's your second sort of area with this. And then here we have got some images. I know they're not particularly nice, but they just help to understand this idea of cortical atrophy. So over here, we have got a brain that has a little bit of cortical atrophy, okay, a little bit of loss of neurons. So you can see around the edges here, the sulci, which remember are the grooves, getting wider around the edges, and in the frontal cortex, and a little bit at the back actually. Okay, so this would be have, you know, an effect on a person's symptoms, but they would not be as bad as obviously the middle picture, and they get worse as the pictures go on. So this one, as you can see, sort of more central to the brain, the sulci have started to widen here and here on both hemispheres of the brain, and also down the centre, so just by your limbic system or your thalamus and your pons. Okay, and then this one is quite significant, and this would be, you know, somebody that has quite a severe form of schizophrenia or psychosis, and they are really struggling with cognitive dysfunction. So again, this is almost all over the brain, isn't it? The sulci have widened a lot, and there seems to be a lot of sort of shadows, and it almost looks as if the two hemispheres have actually split in half here. So there you go. There's a few examples of cortical atrophy and how the brain would look with that disease. Okay, I'm not going to show you this video, but what I will do is I will make sure that you're able to access it through the links on the website. This video is really interesting. The gentleman in the video has posterior cortical atrophy. So remember, posterior is the back of the head, And what he's trying to do is a really, really simple task that we would find very, very easy and very normal. He's trying to push his mattress up against the wall. It has slipped down and he wants to push it backwards. He is being given quite clear and very simple and concise instructions on how to do that, and he is not understanding those instructions. He doesn't have the perception or the cognitive function to actually do that task, and it takes him, the video is about 2.5 minutes long, and it takes him a considerable amount of time to understand what the lady is asking from him. So at one point he is on the bed and he's trying to push the bed against the wall, but obviously we know, because we are, we have cognitive function, that you wouldn't be able to move it if you're on it. You need to step off of the bed and then push the mattress against the wall. He doesn't have that process. He doesn't have that cognitive function. He hasn't got the perception that he is weighing the bed down. It's a really interesting watch, and it's quite agonizing in a way, because actually you really want him to be able to do it, and you can really see how difficult he finds the whole process. So a really nice example of how cortical atrophy is sort of attributed into real life and real behaviour. All right, back to a little bit of cortical atrophy evidence then. You have got Antonio Vita, and again, it's a CT scan, so a really scientific way, to assess 124 individuals with schizophrenia and 45 control group participants. They found that 33% of the individuals with schizophrenia showed moderate to severe atrophy. So 33%, it's not, tons, but it's still a considerable amount of people that have that atrophy. And again, a really scientific method to back up. Okay, this is another picture of the brain where cortical atrophy is evident. So the A side of the brain, there isn't that much sort of gapping in the sulci. However, in B there is. So you can see that from a real life example. That one would be all over the cerebral cortex, wouldn't it? Okay, so it's not focused in a particular area, it's all over. Okay, and our last element for this is something called reversed cerebral asymmetry. The idea of this is that one hemisphere is larger than the other. In most individuals without schizophrenia, the left hemisphere is slightly larger than the right hemisphere, which means that we have cerebral asymmetry. Okay, our left hemisphere is slightly larger. Now we know that our left hemisphere is to do with language. So does that mean that, our left hemispheres are slightly larger and that's why we're able to communicate with people through language, through body language, and etc. And our right hemisphere is slightly smaller. However, in people with schizophrenia, that is reversed. Obviously, it's called reversed cerebral asymmetry. So that means that the right hemisphere is notably larger than the left hemisphere. Our language hemisphere, the left one, is smaller in people with schizophrenia. Now, I'm hoping that you are able to identify how that might link to a characteristic or a symptom of schizophrenia. We have got the symptom of alogia, which means poverty of speech, where you are quite quiet, unable to make or form a coherent sentence, and you don't really speak that much. Now, if we know that our left hemisphere is to do with language and people with schizophrenia have a smaller left hemisphere, that would explain that symptom, wouldn't it? So it says here, this is relevant when considering that language function is normally found in the left hemisphere. So damage or deterioration in the left hemisphere could lead to the poverty of speech, alogia, which is often seen in schizophrenia. It's a negative symptom of schizophrenia, and we know that that was classified by Kurt Schneider. He classified them into positive and negative symptoms. Positive meaning in addition to normal behaviour, and negative meaning taking away. So alogia is a negative, isn't it? So it's being taken away from normal behaviour. So we're taking away our ability to produce speech. Okay, right. Let's have a look at this then in terms of a question. So what it's asking you is outline the structural abnormalities explanation of schizophrenia. Normally about 10 marks. And this is an AO1 question. An AO1 question means that it is information, isn't it? It's you recalling and telling the examiner what you know about structural abnormalities explanation. An AO2 question means that you have to apply your knowledge to a scenario. So you may be given a case study about somebody with schizophrenia or a different behaviour, and you have to pull the information out and apply your knowledge to it. And then an AO3 question is an evaluation question where you look at the strengths and the weaknesses around that research, and you bring in new research to back up those strengths and limitations. So we're going to look at this AO1 question. It's normally one of the first questions that will come up on the exam for behaviour, and then it normally is followed by an evaluation question. The 5 bullet points that I have written here are just some tips really on what I think should be included in an answer to get 10 marks. So starting off, I would ask yourself, well, what do structural abnormalities suggest? Okay, what are they? What's their impact? Talk about that background evidence. The fact that Emil Kraepelin had this idea of an organic brain disease, but it was completely overlooked because Freud's theory came out at that time and people went with that instead. It wasn't until we had significant brain scanning techniques that actually people thought, oh, hang on a minute, maybe schizophrenia isn't about the way that you're brought up, or it's not about your childhood experiences, or it's not about the way that your mother treats you. Maybe it's actually biological and it's the structure of our brain that influences our behaviour. Okay, that's what I would add for that first bullet point. And then you're going to start showing off your knowledge. What the 4 ventricles in the brain are and what they do. So you need to explain to the examiner that there are 4 ventricles in the brain. You've got 2 that are called the lateral ventricles, 1 in each hemisphere. You have got your 3rd ventricle, which is situated by your thalamus. And then you've got your 4th ventricle, which is between your pons and your medulla oblongata. Those key words, those key terms and areas of the brain are what you will get the marks for, because we look at terminology. And when I show you a mark scheme in a few slides time, you'll see that terminology is super important when we're doing questions like this. So those areas of the brain and where the ventricles are really important. Another thing you can add is, what is a ventricle? It's a space in the brain that creates and stores cerebral spinal fluid. Why do we have cerebral spinal fluid? For buoyancy, protection, and chemical stability. Then you've got to give me some evidence, okay? It's all well and good us telling the examiner everything we know, but we need to add a bit of evidence. What's so good about it? Okay, what have researchers found out about CAT scans and MRI scans? So you've got Daniel Weinberger, you've got Nancy Andreson, you've got Antonio Vita, who have got some great, really scientific and significant research. Remember those percentages, okay? Ventricles are 20 to 50% larger, okay, in people with chronic schizophrenia. It's those really specific statistics that will really impress the examiner, okay? So they're things you really need to remember. And then you'll move on. What is cortical atrophy? Okay, it's a loss of neurons. The sulci in your brain get wider, okay? It impairs cognitive function. What are our cognitive functions? Memory, perception, cognition. it means that, you know, you can have it in the front of your brain, the back of your brain, or all over your cortex. What is the evidence of that? Okay, 33% in that sample showed signs of cortical atrophy. And then you move on to your third one, which is reverse cerebral asymmetry. So people with normal functioning brains have cerebral asymmetry, which means that our left hemisphere is larger than our right. And then people with schizophrenia have that reversed. Their left hemisphere is smaller than their right hemisphere. What would that mean? Okay, how would that link to the symptoms or the characteristics of schizophrenia? Well, we know it's alogia because our left hemisphere is to do with language. Okay, so take it step by step with this question and make sure that you've got an element of all three structural abnormalities. Okay, so the ventricles, the cortical atrophy, the reverse cerebral asymmetry, and make sure you've at least got one piece of evidence for each structural abnormality. In the examples I've given and in the work and the notes that you probably have quite a few bits of evidence. I would absolutely make sure that you've got at least one for each element of this. Okay, so here is an example of the mark scheme. Now you will know that the exam answer I've just gone through would be a 10-mark question, but what the exam board can do is they can actually give you this for 5 marks, which is quite tricky really, because 5 marks doesn't seem like that much, especially when you've got so much that you are able to talk about. This is a mark scheme that is quite vague really, and it doesn't really give you specifics of it. It says, description of explanation is thorough and accurate. There's depth in range in the material included and effective use of terminology. So that's where our ventricles come in. Okay, where are they? Where are they in the brain? Okay, that's how we get that terminology. Depth and range comes from the evidence that you use in your answer. That your description is correct, that it's not brief, and that you've gone into detail. You've shown off to the examiner that you know exactly what structural abnormalities are. That's how we're going to get full marks in this. One thing you can be asked in the exam is to describe 2 biological explanations of schizophrenia, and it might be a 10-mark question. So it would be 5 marks for each explanation, 5 for the dopamine hypothesis and 5 for structural abnormalities. And that's fine, okay? We just need to make sure that you've got an equally balanced amount of depth and range for each one. You can see the real difference in the wording that's used on this mark scheme. You know, it's thorough, effective use, there's depth and range, there's a logical structure, and that's why I've given you those bullet points to use as an example, because you need a nice structure. You need to say what the structural abnormality is and then give me a piece of evidence. Structural abnormality, piece of evidence, because that shows that you can logically structure your answer. In the 3 to 4 marks, it says description of explanation is reasonably detailed. There is depth and range, but not in equal measure. So you may get all of the terminology correct, but you may not have given me any evidence. Okay, that would mean that it's not really equal, and it would lead to 3 or 4 marks. Good use of terminology, structure is mostly logical. And then we've got 1 to 2 marks, which I know that nobody will be aiming for, but it says description of explanation is basic, in detail and accuracy. There's depth or range, and there's some use of appropriate terminology. And then the answer lacks structure. So if it's a bit muddled and you're getting your different structural abnormalities mixed up, it would be a 1 to 2 mark answer. And then obviously no marks is if it's completely wrong, or no response admitted, which nobody will get because we all know that we can answer this question. Another mark scheme that we have here is if it was a 10-mark question. So it says description of 2 explanations of schizophrenia is thorough and accurate, but this would also apply if you were asked about 1 explanation. So for 9 or 10 marks, that top mark band for this AO1 question, again, depth and range of material included, effective use of terminology, logical structure. Something to note here is the difference that you have an or when it gets to the basic sort of area of the mark scheme. It says description of 2 explanations of schizophrenia is basic in detail and accuracy. There is depth or range only in material used, some use of appropriate terminology, reasonable structure, or description of 1 explanation of schizophrenia is thorough and accurate. So if you only look at 1 explanation, or if only one of them is accurate and the other is rushed, it would mean that you'd be capped at 3 to 5 marks, of half marks. So again, when we're looking at planning an answer, you need to make sure that you have obviously an even amount of detail in each section for each explanation, each biological explanation here. One of the things, and one of my best tips that I tell a lot of my students, is that when it comes to revising things like this, it can become quite overwhelming because there's a lot of information. The first and the best thing that I would say is learn your terminology, learn your terms. If you create a keyword glossary and you write on that all of the psychology specific words that you need to know. So number 1 could be lateral ventricle. Number 2 could be third ventricle, thalamus, medulla oblongata, pons. Okay, and if you're able to give me a definition of where they all are or what element of the course they link to, it just means that you absolutely will have that effective terminology, which really will bump you right up that mark scheme. And get you those higher marks. So if you're really struggling on where to start with revision on this, absolutely a key term glossary is where I would start. Once you've got all of your key terms and you can define them, then you can start putting them into an exam answer. But it's not until you know the terminology can you then apply it to actually writing it in an essay. So that's my best advice when starting to revise this element of the course. Okay, that is all for today with structural brain abnormalities. The next session that you will see will be individual differences, explanations of schizophrenia. What I'm going to do is combine 2 together. So you will look at Freud's psychodynamic theory and also the cognitive theory with Anthony Morrison, Christopher Frith and Aaron Beck. And we're going to look at, again, a description of the core knowledge and research around the cognitive and psychodynamic aspects of schizophrenia. The session after that, I will be looking at some exam technique for Unit 3. I'm going to do some example answers and we're going to work through them. Why are they good? Why are they not so good? Where have they gained their marks? And I'm going to focus those on the elements that we've looked at. So dopamine hypothesis, structural brain abnormalities, and those 2 individual differences. So if you want to see an example of an essay question on structural brain abnormalities or the dopamine hypothesis, they will be in session 4, the exam technique for Unit 3. Now we have got about 5 minutes left of this session. Thank you all very much for joining. I'm going to double check now in case there are any questions and I will have a go at answering them. If there aren't, then thank you very much for joining. I hope that this has been helpful and I hope that I will see you in the next section to look at our individual differences explanations.